Okay, now we move on to question 2. And question 2 says in 2.1 we have the first term of a geometric series is 14 and the sixth term is 448. We have to calculate the value of the constant ratio. Okay, so look at the information they've given us. They gave us the first term and they gave us the sixth term. Okay, whenever they give you the first term, and it is a geometric or an arithmetic series or sequence, just note that they're trying to give you the value of a, because the first term, we call that a. So it means that the value of a in this geometric series is 14. Then they're telling us about the sixth term. So they're telling us that the sixth term, T6, is 448. And we have to use this information to find the constant ratio. Because they're giving us a term value, this implies that we're going to have to use the Tn formula to actually find the value of r. So the Tn formula of a geometric series or sequence is Tn is equal to a multiplied by r raised to the power of n minus 1. And we're just going to substitute everything we have. We have the value of a, we have T6 as well. So I'm saying term 6 is going to be equal to, and then a is 14. We have that 14 multiplied by r, which we don't have, and we're looking for that, to the power of n minus 1. So the n value is 6 because we are substituting, you see, 6 in place of n. That is term 6. So that is 6 minus 1. And then now we're going to this is going to become an equation. So what is the value of T6? The value of T6 is 448. So that is 448 is equal to, and we have 14 multiplied by r raised to the power of 5. Okay, this is all we have. We just have to solve for r. So how do we get r on its own? Well, the first thing stopping us from getting to r would be the 14. Not really the 5. The 5 is attached to the r. So we need to first get rid of the 14. So we can divide both sides by 14, seeing that 14 is being multiplied by this r. And let's see what we get. 448 divided by 14. And we get 32. So 32 is equal to r raised to the power of 5. Okay, now focus. You're just trying to find the value of r. And what is stopping us from reaching r is this 5, this to the power of 5. So to get rid of a to the power of 5, you would have to root both sides. So the fifth root of both sides, that would be the inverse of this. Okay, and so this is going to be r is equal to, what is the fifth root of 32? I think that is 2. 2. Okay, so that is 2. So there is the value of r. Okay, moving on to the next question. So 2.2, we have determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of this. Okay, so we're going to have to break down this question. They want us to determine the number of consecutive terms. So consecutive means they come right after each other. And we have to find out how many terms, so really just the number of terms that come right after each other, that must be added to the first 6 terms, okay, of the series in order to get this sum. Okay, so we're trying to find out how many terms, okay, needs to be added to the first 6 terms. We're taking the first 6 terms and we're adding a specific number of terms. We don't know how many they are. That's what we're really just trying to find out. And then the sum of everything ends up being equal to this number. Okay, because we have to actually obtain this number. So 114674. That's really what they're saying. Okay, so let's see how we can break this down. First of all, since we know that we have the sum of the first 6 terms, remember the sum of the first 6 terms is made up of term 1 plus term 2 plus term 3, of course, all the way to term 6. Then we have specific terms that are being added and they come right after each other. Okay, so because they're consecutive, we're going to have to assume that after the 6th term, we're going to have the 7th term, then the 8th term, then the 9th term. But the thing is, we don't know how many of them are added to the first 6 terms in order to get this number. So we're really saying, this is the part we're trying to find out. We have plus T7, plus T8, plus T9 all the way, and we don't really know how many those are, but then they equal this. So they equal this number, right? Okay, so really what we're just trying to find out is this part. How many terms here are added to these ones in order to find this? The good thing about this, we can actually find the first 6 terms, but let's just see if it's necessary to find it or not. Because we know how many terms, first of all, is going to be added to these unknown number of terms. So how about, and we know that they eventually all sum up to this. How about we find out in this sequence, what are the total number of terms that sum up to this number, right? Then when we find that total number of terms that sum up to this number, we're going to subtract the first 6 terms for it, and that will tell us the number of terms that must be added to the first 6 terms. Okay, so we can do that. So let's go ahead and find how many terms exactly was added in order to get this number. Okay, so what kind of pattern is, okay, it's still continuing from this. So it's still the geometric pattern, and we know the value of R. We also know the value of A, so we can use that. So we're going to use the sum formula, and as you can see, R is 2, so we're going to use this formula. So Sn is equal to A multiplied by R to the power of n minus 1 all over R minus 1. Okay, so the sum of how many terms, that's the one that we don't know. We don't know how many terms, so we're trying to find out the total amount of terms that it must be added in order to reach this amount. So S of n is equal to the value of A, we know that, that's 14, and R is 2. So 14 multiplied by 2 raised to the power of, we also don't know what n is still, minus 1 all over R minus 1, which is 2 minus 1. Now the value of Sn, the sum of these terms, it's this amount, right? The total amount of terms. It's 114674, which is equal to, and we can just go ahead and simplify this as 2 minus 1 is 1. And anything over 1 really just stays the same because it's all of this being divided by 1. So I'm just going to keep this as 14 multiplied by 2 to the power of n minus 1. Okay, so since that is like that, we can just go ahead and get rid of the 14 first of all, so that we can get closer to this 2 to the power of n. Okay, so we can divide both hand sides by 14, and let's see what we get here. So we have, and that gives us 8,191, so 8191, and then we can say this is equal to, and we have 2 to the power of n minus 1. Okay, so 2 to the power of n minus 1, we can take the 1 over. That will be 8,100 and becomes a plus 1, 92, is equal to 2 to the power of n. Okay, we have a nice exponential equation. We know it's exponential because the variable is on the exponent. So we just need to make the basis the same. So 8,192 is equal to, and then shift fact. Okay, so that's 2 to the power of 13. 2 to the power of 13 is equal to 2 to the power of n. And now we can solve for n. So therefore, it means that n is actually equal to 13. Okay, so now we finally know how many terms exactly are added in total. There are 13 terms in total, but we just have to find out how many terms exactly is added to the first 6 terms in order to get this. So we're just trying to find out how many terms is added here. In order to find out how many more terms was added, we're just going to say 13 minus the 6 terms. That will tell us how many more terms was added in order to get that. So 13 minus 6, that's all we're just going to say. So if we say 13 minus 6, that is equal to 7. So it means that 7 more terms, okay, were added to the first 6 terms in order to get that number. Okay, there. So 7 more terms were added to those first 6 terms in order to obtain that number. Okay, and that is 2.1.2. Moving on to the next question. Okay, then 2.1.3 says, if the first term of another series is this. So again, they're giving us the first term of another series, so it doesn't have anything to do with the previous one. Okay, so of the another series is equal to 448, and the 6th term is 14. Okay, so the 6th term is 14. Calculate the sum to infinity of the new series. Okay, this sounds a lot like the first question they asked us. They're giving us the first term, they're giving us a term number and its value as well, and they just want us to find the sum to infinity. Okay, if we write the sum to infinity formula down, let's look at what it looks like. It says a over 1 minus r. From this already, because we know they just want us to find the sum to infinity of this series, we know all we need is the value of a and the value of r. So it means the information they've given us is enough to find the value of a and the value of r. With a, simple, we already know that. So let me actually put this one on the side because we're not really using this part yet. Okay, so with a, they told us the value of a was 448. So we know a is equal to 448, no problem. Now we need to find r. It's the same situation. They gave us a, they gave us a term value. So we're just going to use that same method. We're using Tn is equal to a multiplied by r raised to the power of n minus 1. And they gave us T6. So T6 is equal to, again, 448 multiplied by r, which is, we don't know actually, to the power of n minus 1, which is 6 minus 1. Then term 6 is actually equal to 14. So 14 is equal to, we have 448 multiplied by r raised to the power of 5. This looks familiar. Okay, so I find it interesting that in the other one, a was 14 and the term value was this. Okay, but we're still getting somewhere, so we can go ahead and just continue. This is for 3 marks though. Okay, then we divide both sides by 448, and now we get 14 over 448. What does that give us? So 14 over 448 is, okay, I'll put it as a fraction. 1 over 32. So that is 1 over 32. And this is equal to r to the power of 5. Okay, so we just have to make the bases the same. Just remember with these, no, we don't have to make the bases the same. We just have to solve for r. We need to get rid of the 5. So to get to the r, let's get rid of the 5 by fifth rooting both sides, fifth root and the fifth root. And this is just going to be r is equal to, because we know the fifth root of 32 is 2, so the fifth root of 1 over 32 must be 1 over 2. Okay, so that is r. So it actually does have a lot to do with the first one. This is like a reverse of the first one. The first series was kind of increasing. Yes, it was increasing because r was 2. So every time each term kept multiplying by 2, right? But with this one, it's like they just went backwards. So now each term is now multiplying by a half, or in other words, dividing by 2. And I guess somebody would have been able to see that and wouldn't need all of these calculations, because now that I look at it, it seems quite unnecessary, seeing that the first term here was 14 and then the sixth term was this. Okay, so if the first term, we were just supposed to reverse it, but it's okay. We already went through the trouble of finding the answer. Okay, so this is really what I mean. In the previous one, the first term was 14, the sixth term was 448. And we were multiplying by 2 on each term. Okay, that was the ratio, 2. That's why it was increasing. But now in this current one, the first term is 448, the last term is 14. So this just shows that we're doing the reverse. Because when we started here, we're ending here. But now since r here was 2, here r would be a half. Okay, so here it was doubling it, now it's halving it. So you could have found r easily like that without all of this calculation. Okay, but anyways, we just have to find the sum to infinity, and now we can just use that formula. So the sum to infinity is equal to, the a value here is 448 over 1 minus the r value is a half. And let's just see what this gives us. Remember, 1 minus our half is a half. So this is the same thing as saying 448 divided by a half. So I'm just going to say that. 448 divided by a half is equal to 896. Okay, so 896. Okay, moving on to the next question. The second thing I want us to look at is this. Before starting to expand and all of that, let's just figure out what type of pattern this is, okay? First of all, if you looked at it straight away, what type of pattern would you think it is? Okay, it is not geometric. It's actually arithmetic. You have to think about it like this. With geometric, you're always going to have an exponent that is a variable, okay? An exponent of like p, for example, or r. But here we don't have any exponent. We just have this. So this definitely cannot be geometric. And the reason it is arithmetic is because arithmetic equations, they will either look like this, for example. But if you simplify this type of equation, you could end up with something like this. See, if we say 2 and then we multiply that in, that's going to be positive 3n minus 3, which is really 3n. And then if we say 2 minus 3, you get minus 1. You see how this looks? This is a simplified version of what this one would have looked like. So it's not always going to look like this. But when it looks like this, you just need to know what is going on here. Remember, here, this was in the form of a plus n minus 1 times d, meaning 3 was d. As you can see, d is here. The difference is always going to be next to n. Okay, it's going to be the coefficient of n when it is put in its simplified form. So this is in the form of dn plus c. So this already tells us the value of d, first of all. So now looking at this, what type of equation is that? What kind of pattern does this belong to? That would be arithmetic, okay? Because it's in the form of dn plus c. Here's a number, here's a variable, here's d right in front of the p, okay? Which is the coefficient of it. So now we already know from this that the difference here is 1 over 3. Okay, so I'm only trying to focus on what you need to find so that you just don't go and expand and waste time in it, but you don't have to do all of that. Okay, so focusing on the things that we need. We know that we're going to use the sum formula because this is the sigma, this is sigma. So we're going to be using, we can say Sn is equal to, now we have d. So you can just go ahead and use the formula, the arithmetic sum formula that has d. So that's n over 2, open bracket 2a plus n minus 1, and then times d. From this, you would see that the only things you need is, first of all, you need a, you need d. So let's go ahead and find a. A would just be your first term. But here you need to be careful. First term doesn't mean T1. It is T1, but it's not where you substitute in place of P1. You substitute in place of P0 because this is where this sum says it is starting from. So we're going to do that to find term 1. So term 1, or our a value, we would just go ahead and say 1 over 3 multiplied by our starting point is 0. So 0 in place of P plus 1 over 6. Okay, so as you can see, that will become 0. Our a value is just 1 over 6. So there we have a. We know what d is. D is 1 over 3 as the difference. And we also, well, we don't know how many terms must be added yet. Okay, but we do know the sum of it. So we have Sn. We have Sn. And we just have to find n. Okay, so Sn is 20 and 1 over 6, which we can, of course, put as an improper fraction, which is, you can't do that on the calculator, but 20 times 6 is 120, plus 1 is 121 over 6. So we can also just do this as well. Okay, so now we're actually ready to find that we have a, we have d, and we have Sn. So we need to find n. Now, there is a reason I left this here. N, right, in the sum formula will always stand for the number of terms. Remember the story I just gave here with, you have to actually check where it starts and where it ends. We know where it starts, where p is equal to 0, okay? And it ends at k. So please be careful. K, whatever the value of k is not the number of terms, okay? That's just where it ends. That doesn't tell you how many terms they are. Just like here, 5 is not the number of terms. It just tells us where we end because we found that there are actually 6 terms in this, okay? But now remember, we are specifically trying to find the value of k, meaning we're not trying to find the sum of the number of terms. We're not trying to find out how many terms exactly was added in order to get this number. We're just trying to find out where this ends at k, okay? So because of that, I'm already going to say this. The number of terms, right? This n over here. We find that by saying, we're going to say top minus bottom plus 1, okay, which is going to be k minus 0 plus 1. So the number of terms specifically is k plus 1. It's not just k. And I'm going to keep that on the side, and that's going to be useful at the end to find the value of k. Let's just be careful. We know that this n here means the number of terms, but k is just telling us where we're ending at. Okay, so let's use the SN formula. We know the sum of the terms is really this number. So we're saying 121 over 6 is equal to n over 2. Well, we don't know what n is, so n over 2, open bracket, 2 multiplied by a, which is 1 over 6, plus n minus 1 multiplied by 1 over 3 as d. Okay, so we're just looking for the value of n. So to find the value of n, let's go ahead and just simplify. We're just trying to make n the subject. So we can start simplifying from inside the equation there. So 121 over 6 is equal to n over 2, open bracket. So 2 multiplied by 1 over 6, you can also just use a calculator. That would be 1 over 3. And then plus, we could just FOIL out, I guess. So we can just multiply that in. So plus 1 over 3n minus 1 over 3. And now we have inside this 1 over 3 and 1 over 3 would cancel. And you're left with 121 over 6 is equal to n over 2 being multiplied by 1 over 3n. Okay, so 1 over 3n can be rewritten as n over 3. And this is the reason why, because 1 over 3 and n is next to each other. When things are next to each other, they're being multiplied by each other. So since they're being multiplied by each other, this n is on the numerator. Its denominator is 1. It's like multiply the numerators, which would give you n. 1 times n, and 3 times 1, which will give you 3. So it's n over 3. So I'm just going to rewrite that as n over 3 instead. And now when we multiply here, the numerator will multiply by the numerator and the denominator times the denominator. So I just have 121 over 6 is equal to, that would be n squared over 6. And now we just have to solve for n. Okay, so n squared. Now, whenever the denominators are the same, they're equivalent fractions, you can drop the denominators. The reason we drop the denominators, it's really like you're getting rid of the 6 by multiplying both sides by 6. And so that cancels. And now we just have 121 is equal to n squared. And we can solve for n by square rooting both sides. But this is, of course, going to be the plus minus. But this is n, so it's always going to be positive. So n is equal to positive or negative 11. But obviously, n would be equal to just positive 11. So we found the value of n. Now remember, n is the number of terms in the series. It's not the value of k. It's just the amount of terms. Like with this explanation here. Okay. N tells you how many terms there are. We found out that there were 6 terms here, not 5. Okay, so you have to think about it like this. Because we started at 0, k would not be 11. It would be 1 less term. Like I explained here, I said n is going to be the total number of terms. We will find that by saying k plus 1. Okay, top minus bottom plus 1. So if you use that, you'll be able to find out exactly what k is. Okay, so that's going to be n is equal to k plus 1, which is really just, we know n is 11, which is k plus 1. And we're taking the 1 over 11 minus 1 is equal to k. So it means that k is equal to 10. Okay, so that's what I meant by k is going to be 1 less term because that is what we are ending. But the total number of terms, okay, would be 1 more than whatever k is. Like here, total number of terms is 6. But we are ending at 5. So just be careful with that. Remember what everything stands for. This is where you start. This is where you end. You know how to find how many terms there are now. And know that the number of terms, okay, in that SN formula, that's what the N here stands for. Okay, so that is it for question 2. And then we will move on to question 3. Okay, so now we're on question 3, and this is what question 3 says. It says, it is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9, and the first term of the first difference is 7. We need to show that b is equal to 4. Okay, so to show that b is equal to 4, first of all, what can really always help you with quadratic patterns is to expand this quadratic pattern just so that you can see what you have. So quadratic patterns, first of all, you would have the quadratic pattern in the first row. Now let's see what they gave us about that quadratic pattern. Now, if you notice, we don't even have the first term of the quadratic pattern. We only have this. Okay, so they only told us the value of clearly A and the value of C, because remember the quadratic pattern is in the form of Tn is equal to an squared plus bn plus c, right? So it means that they gave us the value of A. So A is equal to that invisible one that is over there. So we know what A is. A is equal to 1. So A equals 1. Now, the quadratic pattern is supposed to look like this. You're supposed to have your quadratic pattern where you have your first term, your second term, your third term, and so on. Then, if you set the second term minus the first term in the quadratic pattern, you end up with the first term of your first differences. Okay, so let me actually write these over here. So that's your quadratic pattern. And then if you set the third term minus the second term in the quadratic pattern, you'd end up with the second term of the first differences. So this would be your first differences that you have over here. So looking carefully at what they just said, they gave us the formula, but it's incomplete because B is not there, and the first term of the first differences. So we have the first term of the first differences, which is this over here. We know that this is 7. Okay, and then of course we don't really know what the constant difference is. Okay, so let's see how we can use this to find out the value of B. So we have A and we're looking for B. Well, a formula that includes A and B, that's what you're going to have to try and think about. A formula that would include A and B would be that formula over here when you start equating, okay, each row to the certain things they're supposed to be equated to. Like the second difference is supposed to be equal to 2A. This, okay, the first term in that first difference is supposed to be equal to 3A plus B. And this is perfect because you see, we have the value of A, we're looking for B, and we have a number. This is an equation. So we're going to use this in order to find the value of B. So we're going to say, therefore, it means that 3A, when we know that A is 1, 3 times 1, plus B is equal to 7. And so that is just 3. 3 times 1 is 3. So we have 3 plus B is equal to 7. So B is equal to 7. And we're going to take that 3 over and becomes minus 3. And so therefore B is equal to 4. Okay, so that's how we find B. We knew the value of A. We knew that this is supposed to be equal to this. And it includes A and B. And we're able to solve. So just be thinking about the quadratic formula like that. It helps you to really understand what's going on. Okay, moving on to the next question. Okay, and 3.2 says determine the value of the 60th term of this pattern, which is great. This is a way that you can really score marks. So even if you didn't know the value of B, you see, they're saying show that the value of B is 4, so you'd still be able to get these marks. So the 60th term, this would be term 60. So that just means that in place of n, you're just going to substitute 60 into your formula, your general formula. Our general formula is now Tn is equal to n squared. So Tn equals n squared. Now we know the value of B is 4. So that's plus 4n. And then, of course, that constant of plus 9 at the end. And now with this, we can just substitute 60 in place of n. So we're saying term 60, the 60th term, is equal to 60 all squared plus 4 times 60 and then plus 9. So T60 is equal to, let's just put this onto the calculator and see what we get. Okay, when we substitute 60, I get 3,849. So that is term 60. Okay, moving on to the next question. So question 3.3 says, determine the general term of the sequence of the first differences of the quadratic number pattern. Write your answer in the form of TP is equal to MP plus Q. So we just have to find the general formula, okay, of the first differences in that sequence. So the general formula, in order to find this, and this is for 3 marks. So we're going to need the first differences. We're going to need the value of D, okay, that difference, and we're just going to have to simplify it to this form, okay? So to find those first differences, well, first of all, we have 7. We already have the first term. We can just find the second and the third term. To find those terms, though, we're going to have to use this top, okay? So if we can find the first term, the second term, okay, we don't really need the first term. We already have this, so it's okay. We just need the second term, the third term, and the fourth term. That way, we'll be able to use that to find the second and the third term of the first differences. Okay, so let's go ahead and find that. We're just going to use the formula, this formula. So if we substitute in place of n, we're going to substitute 2 because we just want to find term 2. So if we substitute 2, let's see what we get. We get 21. So I'm just going to find those ones first. So first of all, I have the 21 as term 2, of course, of that quadratic pattern. Then to find term 3, I substitute 3. And I have 30 as term 3. Okay, so I didn't know the first term, but it wasn't really necessary because I already had the first term of the first differences. So all I need here is the second term, first of all. So 30 minus 21, we're going to get 9, okay? And then I will just need like a fourth term. But it's really not necessary. With 2 terms, it's enough because you know this is already going to be a linear pattern either ways. Okay, but if we find the fourth term, here in the quadratic pattern, it is 41. So if you say 41 minus 30, you're going to get 11, which is your third term in your first differences. So it means your first differences just look like this. It's just 7, 9, and 11. Okay, and this keeps going. So with this, we can just go ahead and find this formula. So first of all, we're going to need the difference. The difference, you say 11 minus 9, which is 2. And if you said 9 minus 7, it's also 2. So we can see that that is constant. Okay, so we have this now. Okay, so now that we have that, I can say that the difference is 2. And we can just now find the formula. So the formula of the first differences, remember this is an arithmetic pattern. The first difference is an arithmetic pattern. So we have Tn is equal to A plus n minus 1, okay, multiplied by D. So this is going to be, in order to find the formula, I'm going to say Tn is equal to, I need A, which is 7, plus n minus 1 times 2. Then let's just simplify this so that it can be in this format. Because you see, they're being specific. They want it to look simplified like that. So we're going to say Tn is equal to 7, and then we're multiplying this 2 into this bracket. So it's the 2 multiplied by the 2n and the 2 multiplied by the negative 2. But I'm just going to start with the negative 2 because I want the numbers to be together. So if we multiply, we're going to get 2 multiplied by 2n is positive 2n, and 2 times negative 1 is negative 2. So this is Tn is equal to, I'll just put the 2n first so that it is in this format. And then we have 7 minus 2, which is equal to positive 5. Okay, so this is our formula. But then, of course, they do want you to write it like this. So I'm just going to say that Tp is equal to 2p plus 5. Okay, so that's what they want. And that is it. So we know the value of m and we know the value of q. Okay, moving on to the next question. Okay, and now we're on the last question. 3.4 says, which 2 consecutive terms in the quadratic number pattern have a first difference of 157? This question keeps showing up. Okay, it shows up in different ways. So you need to remember how these things work, okay? They just want to know which 2 consecutive terms, okay? So 2 terms that come right after each other, consecutive. In the quadratic number pattern, okay? So in that quadratic pattern, have a first difference of this. For you to understand that question, try to use a simpler example. And this is what I mean. So you see, we already have this. We already know what our pattern looks like. I'm going to just take this as it is and put it down there just so that we have this. Okay, so if we have this, we don't have the first term, of course, but it's not really necessary. You can find it if you want to. Now, if we have this and we know the constant difference is 2, This is really what they're saying. They're asking which two terms that come right after each other in the quadratic number pattern. Okay, so which terms in this pattern will have a first difference of this? If I try to make this question look simpler, just using what we have here, I could ask you which two terms, okay, in this quadratic number pattern have a first difference of 11. Then you would tell me, oh, that is term 3 and term 4, because of course we have a term over here. That's term 1. Okay, so that'll be term 3 and term 4. So if I also asked which two consecutive terms in the quadratic number pattern have a first difference of 9, you would say term 2 and term 3. So I want you to see the pattern that is going on. The two terms, okay, the two consecutive terms that will have a specific first difference. You saw that in this case, right? It was term 2 and term 3. But in the first difference, that first difference of 9, okay, that is the second term in the first difference. Now, the two terms in the quadratic pattern would be the second and the third term. Likewise with this one, I asked which two consecutive terms in the quadratic pattern would have a first difference of 11. You can see that 11, that first difference, is the third term in the first difference. Therefore, this means that the two consecutive terms in the quadratic pattern would be the third term and the fourth term. You see, it's the current term that you're on and then the next term. That's how it's going to work all the time. Okay, so if this is T3 over here in this first difference, the two consecutive terms in the quadratic would be the third term and the fourth term. So all we have to do here is find out which term exactly in the first difference belongs to that specific number they're speaking about. So if we look up here, we see that they ask which two consecutive terms, okay, in that quadratic pattern has a first difference of 157. So let's go to the first difference and find out which term exactly has a value of 157. Okay, so we'll be finding out that. Then we'll be able to find out which two consecutive terms in the quadratic. So to find out which term has this value, we're going to take the TN formula or the TP formula of this pattern, and we're going to make it equal to this because we're trying to find out exactly which term that is. Okay, so we're saying the value of the term is 157, and we're making this equal to 2p plus 5. Okay, so that we can find its term number. It's the same thing as Tn is equal to 157. Okay, because you're trying to find out what the n value is. What is the term value belonging to this number? Okay. So let's go ahead and just solve for p. You can take 5 over, that will become a minus 5. 157 minus 5 will be 152 is equal to this 2p. Then we can divide both sides of the equation by 2. And so 152 divided by 2. So 50 divided by 2. You can just use a calculator though. Okay, so 100 divided by 250, 20, that's going to be 25 plus 1. So that is 76. Okay, so P is equal to 76. P equals 76, right? So it means that the term here in the first difference, it's the 76th term, 76. So the two terms in the quadratic pattern that's going to have this first difference, okay, of that 157 would be the 76th term and the 77th term. So I want you to always see how that works. So you can answer them by saying, therefore, it will be, you can just read the way the question was asked. They asked which two consecutive terms will have this. Okay, so you can say the 76th and the 77th term. And there we go. So that is the final answer for question 3. And we're done with question 3. And then we move on to question 4, which is on functions.